Hi there. We're going to have a look at something called index rules, and it's really looking at how to simplify expressions when we're dealing with numbers in power form. So just a quick reminder, when we're dealing with numbers in power form or expressions in power form, that number there is called the base, and then this number here is called the exponent or the power. So that is 2 to the power 4, and it can be expressed like that in full. We can have negative powers as well. So if we're looking at something like this, 2 to the power of negative 4, what that actually means is 1 over 2 to the power 4. So that negative there means that we're actually dealing with a very, very small number. So this is 1 divided by 2 to the power 4, which is equal to 2 to the power 4 is 16. So that is actually equal to 1/16, which is a really small number. So whenever you see a negative power, it means we're dealing with really, really little numbers. So when we're multiplying or dividing with powers, there are ways in which we can simplify these expressions. So if we've got 3 squared times 3 to the power 4, that can be written as such. So 3 squared is 3 times 3. Then that multiplication sign is there. 3 to the power 4 in purple there is written here. So if you look at the whole expression, you can see that that is 3 to the power of 6. So 3 to the power of 2 times 3 to the power of 4 is equal to 3 to the power of 6. And if you just have a note, or if you just take note of the powers, okay, 2, 4, and 6, the simplification here is that when you're when you're multiplying numbers in power form that have the same base, then you can add the powers. So a couple more examples here. If we look at this one here, the base is the same, so the base is 7. They're all being multiplied, so you can add the powers. So this expression here becomes 7 to the power of 15. So 4 plus 2 plus 9 is 15. If you wanted to, you can write these out in full and just convince yourself that it is 7 to the power of 15. The rule also applies if you've got negative indices. So if we've got 10 to the power of negative 3 times 10 to the power of negative 2, if you add those two indices together, you get negative 5. So 10 to the power of negative 5 is the same as this. So I just want to have a look at how we get that. 10 to the power of negative 3 is the same as 1 over 10 times 10 times 10. And that is multiplied by 10 to the power of negative 2, which is 1 over 10 squared, which is 10 times 10, which is equal to, multiplying fractions, we just multiply straight across. So 1 times 1 is 1. Then multiplying out our denominators, and that actually gives us 10 to the power of 5, which if we convert this to a negative power, we get 10 to the power of negative 5. So the rule applies when you've got negative indices as well, as long as the base is the same. So that's rule number 1. Which is written here. Okay, let's have a look at another example. Okay, say we've got 6 to the power of 5 divided by 6 squared, and if I were to write those out in full, the top line, 6 to the power of 5 can be written like this, like that, and then over or divided by 6 squared is written like that. Now I can sort of like expand this out a bit more. If you notice my color coding here. So I've got 6 divided by 6. So what I've done is I've just separated out those two 6's there, times then another pair of 6's, and then times 6 times 6 times 6. So the note here is that any number divided by itself is always equal to 1. So that 6 divided by 6 will be 1. That 6 divided by 6 will be 1, and then you're just left with those 3 6's multiplied together. So you end up with 1 times 1 times 6 times 6 times 6, which gives us that line of working, which we can immediately see that that is the same as 6 to the power of 3. So if you note the powers again, 5, notice that the base is the same. The base is 6, so 5, 2, 3. So maybe the rule is we subtract the powers. Let's have a look at another example. This one a little bit more complicated, but we're going to use the addition rule number 1 first. In that numerator, 9 to the power of 3 times 9 squared gives us 9 to the power of 5, divided by 9 to the power of 4. So we are subtracting the powers. So 9 to the power of 5 minus 4 is the same as 9 to the power of 1, which is just the same as 9. So this second rule of indices is based on the fact that as long as the base is the same, we subtract the powers. So here's another example here that can be applied even if you end up with a negative power. So I've got 15 cubed divided by 15 to the power of 5. If you write those out in full, we'll write that out in full, you would get that expression there. And again, we're doing some cancelling. So 15 divided by 15 is 1. So just going through. And what you end up with is 1 times 1 times 1 divided by those two 15s multiplied, which is the same as 1 over 15 squared, which is the same as 15 to the power of negative 2. So again, you're subtracting the powers. So that top power minus that bottom power will give you negative 2. So 3 minus 5 is negative 2. So this is rule number 2. As long as the base is the same, you subtract the powers. Okay, a couple more rules which are really important. Rule number 3 here, which we've already come across up here and in previous examples. If you've got a negative power, that's what it means. Rule number 4, anything to the power of 0 will always be equal to 1. And here are a couple of reasons why. So if you just have a look at this here, you can pause the video and just work through it yourself. And the last rule is a rule to do with brackets. So say we've got an example like this, 4 squared all to the power of 3. So whatever is inside the brackets is being raised to the power of 3. If I write this out in full, this is what it would look like. And if you were to write that out in full, actually I'll do it here, you can see that that is the same as 4 to the power of 6. So what we're doing here is we actually multiply the powers if we're dealing with brackets.